All right, section 2 is area. So integral is really just finding the area under the curve. And yesterday we learned this word called antiderivative. Antiderivative means the same as integral. So Riemann sum is going to be a word that you're going to see a lot. Riemann sum is a way of finding that area under the curve. So antiderivative is really just trying to find the area under the curve. And when we say curve, we're talking about the function f of x. And we're actually we're not looking for all the area under f of x. We're looking for the area between f of x and the x-axis. So under the curve f of x and then x-axis. So we're finding the area in between, or else we're always going to find infinite amount, right? It goes down forever. That's not what we're looking for. It's between that curve and the x-axis, just that part. Riemann sum is an approximation. So approximation obviously means it's not exact. It's a very basic way of trying to figure out the area using rectangles. So, for example, find the area enclosed between the curve. That curve is square root x and the x-axis from x equals 1 to x equals 5 using 4 intervals. Okay, we're going to figure out the area underneath square root x and between square root x and the x-axis from 1 to 4, and we're going to use 4 intervals. There are 4 basic methods: the left Riemann sum, right Riemann sum, midpoint sum, and the trapezoidal sum. Do you guys remember this from last year? Yeah. Okay, very easy stuff. It's just kind of like adding rectangles. Okay, so I have this graph of square root x here. We're going to figure out what it is from 1 to 5. But we can't really figure out this exact area. So we're going to approximate it using rectangles. And we have 4 ways of finding the rectangles. One is called the left Riemann sum. So we're going to draw rectangles from the left, 4 of them. And then we're going to use right Riemann sum, which is rectangles from the right-hand side, 4 of them. We're going to do midpoint and then trapezoid. All right. We're going to use 4 intervals from 1 to 5. 4 intervals from 1 to 5. That means each one is how long? 1. Right? From 1 to 5, if I have to make 4 intervals, right, each one has to be 1. Okay? Very easy. Now, you don't want to draw a picture every single time, so I'm going to show you how to do this algebraically. So what is the width? The width is going to be the length of x. So we say delta x. So the triangle is called delta. That's the Greek letter delta. So delta x is how long or how wide that interval is. How do you figure out how wide the interval is? It depends on where to where and how many intervals you want. So where you start, we are going to call that A. Where you end, we call that B. And then how many interval, we're going to call that N. So the width of the interval is going to be the end minus the beginning divided by how many intervals you want. Yes? So it's the length of the total length, right? So 5 minus 1, the total length is 4. You're going to break it into 4 intervals, so then each one is 1 long. Yes?
So that finds the width of the interval.
That finds the width of the interval, yes. Okay, height. Height depends on where you are, right? So you're going to break this into 4 intervals. The first one we're going to do is left Riemann sum. Left Riemann sum means when we break this into 4 intervals, like so, we take the left-hand side of each interval and we use that as the height. So the first interval is between 1 and 2. The left Riemann sum uses the left-hand side, and we draw a rectangle using the height of the left-hand side. Okay? So this is my first rectangle. And then the second interval is it's between 2 and 3. I'm going to use the left-hand side of the interval to create the height. Okay? Easy. And then same thing with this third one and the fourth one. So the height is going to depend on my left-hand side for this case. So it's going to be my function depending on where I am. Right? F of x is my curve. F of that x value tells me how high it is. So then the area is always going to be the width times the height. Right? The rectangle area is width times height. But we're going to add up all of the rectangles. So plus another one, x2, plus another one. And in this case, there are only 4. So we just do this 4 times. Okay? All right, now let's actually calculate this. Left Riemann sum. I think you guys are pretty good with abstract stuff. So I'm going to try to do this a little faster. What is common between all 4 terms? Delta x. So I'm going to take out delta x. So it's just easier for me to calculate because I don't really need to write the same thing over and over. So I'm going to remember that. That's how I'm going to calculate. All right. So left Riemann sum. Left Riemann sum. I'm going to take the width. What's the width in this problem? 1 times the first height. The first height is depending on the left-hand side of my interval. What is the x value that's on the left-hand side? 1. And my function is square root x. So the first number is square root 1, which is just 1. Okay. The second height, between 2 and 3, I'm taking the left-hand side of the interval. Yes, question?
How do you get square root 1?
So the height is dependent on the first interval. The first interval is between 1 and 2. I want the left Riemann sum, so that's the left-hand side of the interval, which is x equals 1. My function is square root x, so this height is square root 1. Okay, so the second interval is between 2 and 3, and I want the left-hand side, so that's going to be a height of what? Square root 2. Okay, and then my third interval is what height? And then the fourth one? Yes, square root 4, which is 2. And then you just solve. So you can just use your calculator, figure out what that number is. $6.146. All right, right Riemann sum. I'm going to change it to a different color. Same idea, except in each interval, I take the right-hand side. 2, 3, 4, 5. Okay, so same width, but 2, 3, 4, 5. Good? Easy? Okay. So calculate that. Is it 7.382? Okay. Next one, midpoint. So midpoint is a little bit trickier. We're taking the middle and we want the height. So yes, so between 1 and 2, the middle number is 1.5. From 1.5, we go up to the height, and then we create the height. Yes? So 1.5, 2.5, 3.5, 4.5. If this does not make sense, you got to ask somebody. Or me, but somebody. Okay, 1 times square root 1.5 plus square root 2.5 plus square root 3.5 plus square root 4.5. Do you guys have a number, or you're just waiting for me to give you the answer? Eleanor's like, you saw it right through me. 6.798. All right, the last one is the one that you have to remember a special formula. Trapezoid. Do you remember the area of a trapezoid? Yeah, it has to do with base. Okay, so let's look at a trapezoid. Let's say the trapezoid looks like this.
One base plus
Let me label these things, and then so you know what I'm talking about. Base 1, base 2, h.
B1 plus B2 times h divided by 2.
Yes. Base 1 plus base 2 times the height, or whatever you call that, divide by 2. Okay, so you gotta memorize that. Okay, it will definitely be on the test. So, memorize. Yeah, definitely. So you take the height. Well, in our cases, we are trying to create trapezoid. So this is quite messy now. So let's say between 3 and 4. We're taking the height between 3 and 4, and we're drawing a trapezoid. Okay? So in order to find that area between 3 and 4, you're going to say f of 3 plus f of 4 times the height, that's delta x, divided by 2. Yes? Okay? Base 1, base 2, height. Okay? All right. Okay, so we're going to add up all the areas from the first one to the fourth one. So the area is going to be, it's a little bit, okay. I'm going to do this in terms of abstract. So I'm going to just do this in terms of just a formula. So the first rectangle looks like this. Let's say this is x1, this is x2, and this is delta x. Okay, so my first area is going to be f of x1 plus f of x2 times delta x divided by 2. Okay, second one, f of x2 plus f of x3 times delta x divided by 2 plus f of x3. To be honest, you don't have to copy this down because I'm going to simplify this formula, which is why I'm showing you this. So you just need to know how I get to the final one. All right. I am going to simplify this by taking out the greatest common factor. What is the greatest common factor? Good. Delta x over 2. What's left?
The rest.
Yeah, the rest. Let's try to combine it in our mind, if you can. F of x1. Plus 2 f of x2. Yes. Plus 2 of f. And then f of x5. Yes. So everything in between, there are 2 of them, and then the 2 on the end, there's only 1. Okay? All right. Now let's apply this formula to our example. Our example says the delta x is 1 over 2. The first height is square root 1. The second height is square root 2 plus 2 square root 3 plus 2 square root 4 plus square root 5. So if you just remember that formula, it would be very useful. If you don't, just remember you're adding up all the trapezoids. I'm not going to calculate that one. It should be pretty easy to just punch it into your calculator. Let's just practice. All right. F of x is 1 over x. Figure out the area bounded by the graph of x-axis and the lines 1 to 2 using 4 rectangles and a right Riemann sum. Okay? You don't need to draw a graph. Right? You don't need a graph. You can imagine it if you want, but what you need is, you know it's a right Riemann sum, you know there are 4 intervals because 4 rectangles. You need to find the width. You need to figure out what is on the right hand side of each width so you can figure out how long that is. And that's it. So try it.
So right hand side.
Let's kind of do this together. So first you need the width. The width is going to be b minus a over n. This is a, this is b, 4 is n. So this is going to be 2 minus 1 over 4, which is 1/4. This is using the right hand or the right Riemann sum. So we're going to take the width times figuring out the right hand side. So if you're really not that good at figuring out the right hand side, what you can do is just write out all the intervals. The next one is 1/4 bigger, and then 1/4 bigger, and then 1/4 bigger, and then the last one is that one. So you want the right hand side. Okay, plugging all those numbers into f of x. So 1 over 1 and 1/4 plus 1 over 1 and 1/2 plus 1 over 1 and 3/4 plus 1/2.
Don't have a times 2.
Huh?
Times 2.
No. Why times 2?
I think we're only on the
No, that's for trapezoid. This is for the right.
Oh, you're
Riemann
doing
sum.
that. Oh, sorry.
Yeah. So the answer is 0.635. All right, let's talk about this a little bit. The question is this an underestimate or overestimate? All right, let's look at the graph. The graph is like this. You're going from 1 to 2, and you're using the right-hand side. So is it a over or underestimate? Okay, underestimate. Now, if you had to explain and you say, why is it an underestimate? You would say, it is an underestimate because, why? What do you think? It doesn't have to be concave up because it could concave up this way and then you would be an overestimate. Yeah. Okay, right values are smaller. Let's try to use it in a calculus way. The what? The derivative is negative. That's good. What's another way?
F of 2 is less than F of 2.
That's what Sophie was trying to say, but it's calculus. Yes. That's what Elizabeth was trying to say. Yes. Yes. The graph is decreasing. Because derivative, yeah, that's also good. Because f of x is decreasing. So this is how you're going to explain whether it's overestimate or underestimate based on whether your graph is increasing or decreasing with the method that you're using. Yes?
Do we have to say that we were using right Riemann sum?
No, because that's in the problem already. Yeah. All right, let's try another one. This is a very typical problem where you have a table. All right, they give you a table from x equals 6 to 24. Only selected values are seen. They say that R is a region bounded by the graph of f, x-axis, and the lines x equals 4 to 24. Find a trapezoidal approximation of the area of R. R. What's R? I don't know what R is. A region? Oh, sorry. Yes, you're right. Then it should be a big R. I don't know what it is. Using the subintervals defined by the table. Okay, looking at the table, is it spaced out evenly? No, it's fine. If it's not spaced out evenly, it just means your intervals are going to be maybe like this, which is okay. They're not the same. They just want whatever trapezoid you can get. Okay? All right. So, since the intervals are not even, you cannot use the formula we derived because that formula is saying that you're taking the same width and multiplying everything, but this is not the same width, so you can't do that. You have to do one trapezoid at a time. Okay? All right, so recall trapezoid area. B1 plus B2 times the height divided by 2. Yeah, times the height or the width in this. Yeah. Okay, so the first area interval is between 6 to 12. So let's just find the width. The width is the easiest. What's the width? 6. Okay, what's base 1?
5.
What's base 2?
7.
Okay, divide by 2. First one done. Second interval. What's the base? 8. What's the first base? 7. 7 and then 4. Third one. Is Zach confused? What's your question?
Why did you use the base as
Let me rewrite this so if you got it.
Can you rewrite it? But I think I got it.
Okay, I can't erase it. Okay, h times b1 plus b2 over 2. Okay, let's look at the third interval between 20 to 24. Okay, the height or the width is 4. Base 1 is 4 and 7 over 2. So you just have to calculate that. Let's see. So 3, 36.
Plus 44 plus 22.
Is the trapezoid method also a Riemann sum?
No, it's not. It's a separate thing. Riemann sum is all rectangles.
Oh.
All right. Let's. Huh? No, they only ask you overestimate or underestimate if it's right or left. Trapezoid is usually close to what it should be. So, yeah. They usually don't ask you overestimate or underestimate for trapezoid. Okay. Now, let's go theoretical. What happens if we increase the amount of intervals? Becomes more accurate. And when my interval gets smaller, right? Theoretically, yes. So, it's going to be like our favorite word now. Okay, so the area, let's kind of look at this theoretically. Area is width times height, right? Width times height. And we do that forever. Width times height. Right, we have tons of rectangles, so I don't know how many, so we're going to say n. And we're really just adding up all of these things. So we can just say that you can take out that delta x and you're just adding up all of your height. Another way to say adding up all those numbers.
Sum.
Yes, sum. But in a summation notation, if you recall. Yeah, the sigma notation. So we're adding up everything from 1 to whatever n is. So, and we don't forget that delta x. I'm going to actually write that delta x at the end. So it's going to be f of, and let's just say it's I. And then delta x. Why is it I? Because I'm going to say I is starting from the first number to the nth number. right? I'm adding up first rectangle to the nth rectangle. And what's going to happen is I am going to make it be super many amount of rectangles. That means limit as n goes to infinity. Yeah, when n is very big. And that means I make my delta x very small. Yes, correct. And eventually, this becomes the integral. The integral is f of x. So notice the similarity, f of x, dx. dx is the delta x. So it's height times width. Okay, integral is the smooth curve when n goes to infinity. Okay, so this is how you get from limited amount of rectangles to a smooth curve when n goes to infinity. Good, theoretically.
Everything's theoretical.
Yes. All right, now let's look at some more example. Upper and lower sum. I have like no notes there because it's very easy. Upper sum just means the largest estimate. Yeah. And then lower sum just means the lowest. The lowest estimate. Okay, 2 more examples and we are done for the day. All right, tables. People really don't like tables. That's why we're doing a lot of tables to practice. Okay, so suppose radon gas is leaking into a basement. That sounds bad. At a rate of R of t liters per minute. Values of the rate at 10-minute intervals are given in the table. Find a left Riemann sum and a right Riemann sum to estimate the total amount of radon that seeps into the home over the interval 0 to 60. Oh, that's bad. Okay, so so you have this rate, and that rate is in the unit of liters per minute. Liters per minute. What happens if I multiply that by time?
Velocity.
No. We are not on PVA. If I multiply this by time, time is in minutes. So this is liters per minute. If I multiply by minute, you get L. So when they're asking you how much radon is leaked, you take the rate, multiply by time. Rate multiplied by time is the area. Right? So because they give you the rate, multiplied by the time, that's going to give you the area, which is going to be the amount. Okay, find the left Riemann sum. Let's do a left Riemann sum. You guys can do this. You don't need me.
Wait, are we reading left? Oh, it is.
Left Riemann sum. And it's very nice. They give you the same even interval for the entire table.
Yeah, that is pretty nice.
Which one is x, which one's y? So this is going to be y because that is the rate. If you multiply by the time, that's going to give you the area being the amount of radon. Okay. The amount is going to be the rate times time. This is the rate, this is the time. If you multiply that together, you're going to get amount of radon. Yes, no. Yes, no.
16 to 10.
All right.
Okay.
So which one's the
Scroll
Y?
up.
Which one is the y?
Scroll up real quick.
Do they give us a Y?
They don't give us a y, they give us the y values. They don't give us a function. They tell you at that t, the time, what rate you get.
3, 4, 5, 6.
Multiply them all. Give it like 0.
Yeesh. Okay. All right. In this case, there is no delta x. We have delta t. What's delta t? 10.
Oh, look, I thought I said 10.
Okay. 10.
Yes.
Let's try left Riemann sum.
said 16 versus 10.
Okay.
I get it.
Okay. So left-hand Riemann sum is going to be 10 times the height from the left. 0.01 plus 0. Plus 0.04 plus 0.03 plus 0.02. Do I add this last one?
No.
No. Left Riemann sum, you skip the last one on the right.
Especially because that one doesn't make any sense.
If you add that one?
It doesn't fit with the rest of the graph.
It's a real life situation, so your graph is not always going to increase or decrease. It's going to be random.
10 minutes was really slow.
Huh? Yes.
What's the map? The y-axis would be the r rate and x-axis would be the
Yes.
It's only 0.0.
1.5.
1 point something.
1.5. If it's 1.5, you be dead in like
Okay. So
30 seconds.
you're finding this area, which is r of t times t. That's the amount. Are you getting this?
Yeah.
Where
Yes.
is that just the formula?
It's not really a formula. It's just theoretically thinking like, what is Riemann sum? It's just the area. So, okay, all right, that's the formula. Yes. Okay, so the left Riemann sum is going to give you 1.5 liters. Okay. What is the right Riemann sum?
1.9.
Huh?
Yeah.
Okay,
How do you get that?
1.9.
Or could you just minus the 1 and add 1.5?
Yes, that's how you do it really fast.
Oh, yeah, that makes sense.
All right, let's have you guys try another one, and we are done for the day. A car at a toll booth stops at a toll booth and then proceeds onto the New Jersey Turnpike. The car's velocity in meters per second at various times 0 to 30 minutes is given in a table. Assume the velocity is increasing over time, okay, as the car speeds up to enter the turnpike from an on-ramp. Find a lower and upper estimate for the distance traveled by the car over the interval 0 to 30. Okay, let's do a lower estimate. Lower estimate means you're going to take the lower of the interval. So, is this interval, are the interval evenly spaced out? No, so we're going to have to find one interval at a time. Let's do this one. What is the width on this interval? 2. What is the lower of the two sides? 0. Next interval.
It's not that bad.
So you're just taking the lowest estimate.
So
Right.
this is basically left.
Okay, so what is the width?
3.
3. What is the lower estimate? 2.2. And so on. So go ahead and figure out what is the lower estimate. You're taking the lower of the two. Okay, what'd you guys get?
371.
371.
I got
0.1.
370.
0.1.
Yeah.
Yeah,
Okay. I will trust that you are right.
I promise.
I got it.
You got it.
Got it.
Okay, upper
287.6.
Yeah, that's right.
287.6.
Yeah.
Oh, wait,
Okay,
okay,
yeah,
I'll
yeah.
do the last one.
Okay,
That's the
we
left
shouldn't
one.
add the last.
It's 287.6 for the
Oh, yeah.
287.6. Wow.
It's for the left one.
Wait, why is it lower than
No,
the
I got
lower
the
one?
lower. That's what I got for the lower.
We're
The
doing left
lower-
or right Riemann sum.
The lower one is 287.6.
Yeah.
287.6.
Yeah, and then the higher one should be that.
Yeah. Yeah.
You guys are not using the same interval sides, right? They're not the same interval sides.
Except for the lower we use the lower.
So it's 2 times 0.
No, I'm saying the size is not the same across the whole
Yeah, so
interval.
we
Yeah,
have to do it
yeah.
separately. Each one. Wait, but isn't it?
Okay, all right. I'm going to check this again because I got 400 something for both.
What? Oh?
Okay, I will double check. I will double check.
Yeah, I got 150.
Okay, lower estimate is 370.1. Upper estimate is 464.2.